Here in this video, we are solving two problems that appeared in NEET 2024 in electric potential and capacitance. Let us see the first question. Both are theoretical questions. A parallel plate capacitor is charged by conducting a battery through a resistor. So he is saying that there is a capacitor and then a resistor, and of course there is a battery. So from here a conduction current will start, it will go through the resistor and then it will further go towards the capacitor and it is supposed to come back. If I is the current in the circuit, what happens between the gaps of the plates, right? So the first thing is, when current is passing through this area, as the capacitor is initially not having any charge starts piling up across the plates of the capacitor. As that is happening, there will be a starting of a change of electric field between the plates of a capacitor. As that is happening between the plates of a capacitor, a current is generated. As the voltage is increasing and the charge is increasing and electric field is increasing, a displacement current is generated in the same direction of the conduction current, regular current. So look at the options. There is no current, that's wrong. Displacement current of magnitude I flows in the same direction of I is correct, and opposite direction is wrong. Greater is also wrong. So what is the conclusion to say is, across the capacitor until the capacitor is got charged, the current developed called something like displacement current, who is equal to the regular conduction current, right? Until then the circuit flows current through it. Let's have a look at the second question. In a plate of a parallel plate capacitor connected to a battery are moved close to each other, then what happens? There are two plates separated by a certain distance d, and the capacity of the capacitor is epsilon naught A by d. Now he is saying they are moved close to each other. What happens as they move close to each other? Distance decreases. As this distance decreases and other parameters are constant, capacity increases. So the first thing that you need to understand is, capacity of that capacitor increases, right? Then what happens to charge? Q equal to CV. Battery was kept constant, but as capacity increases, it's obvious that Q also increases. So let's write here what is happening for Q is increasing. Of course, capacity of the capacitor is also increasing. Let's talk about the energy of a capacitor. Is half CV square. Though V is kept constant, as capacity increases, energy also increases. Energy between the plates also increases. Then what happens to Q? Already we have discussed. Now what happens to Q by V? They are the options that what we have. A ratio of something that was given, like we need to find out Q by V. Though V is constant, as Q increases, Q by V as a whole together is going to increase. Then the product of Q and V, what happens to this? V constant, but Q increases, so Q and V product also increases. So these are the things, like Q by V increases, Q and V also increases. So these are the things. Let us look at the options now. Charge stored in the capacitor increases is perfectly alright. Energy stored in the capacitor decreases is not wrong, is not right. It actually increases as capacity increases. Product of charge to voltage increases is okay, is correct, right? Ratio of charge to potential remains the same is not right. It's actually increases ratio, as we have discussed, Q by V. And then the capacity increases is fine, is correct. So who are correct? A is correct, then C is correct, E is correct. Let's look at the options, where they are. This is the option. A, C, E are correct. That's the right option. That's how we solve. So both these are theoretical questions. We need to have some kind of conceptual understanding in solving these questions. Thank you for being here. Thank you.